Hello and welcome. This is another hands-on video where we're going to talk about data visualization, and we are going to do visualization using a very popular Python library which is known as Seaborn. This is a library that's built on top of matplotlib, so it offers you the flexibility of matplotlib. All the customizations, etc. that you've learned in matplotlib would be equally applicable here, but the plots and the outcomes are more attractive, more appealing compared to matplotlib. So for visually appealing plots, we will explore Seaborn. And you will also find in this video that we'll show you some shortcuts where basically you will create one type of plots, and for all the variables of the same nature, you'll be able to replicate that code. That would save you a lot of time. If you're new to this channel, you may consider subscribing and hit the bell icon so that you continue to receive the updates. Please share it with all others who might benefit. Let's get started. So we are importing the basic libraries like NumPy, Pandas, Seaborn, and Matplotlib, and we are not reading the data from outside. We are actually using a dataset that's available within the Seaborn library. It's a dataset called tips. So how do we get this? You have to write the Seaborn SNS.load_dataset and tips. It's a very popular dataset. I'll show you first few records, first 5 rows in fact. So this dataset is about people who have visited a restaurant. This is their total bill amount. This is the amount of tip they've paid. This is the gender of the primary customer. It also captures whether the customer was a smoker or a non-smoker, what day of the week it was, what time it was, like a lunch or dinner, and then finally, how many guests were there. So essentially, the target in this particular data set is to be able to predict the tip amount, and let's get started with it. So first thing to check before we deep dive into visualizations is the nature of the data. While we have an idea while glancing through the first few records, it'll be nice if we clearly see the data types, and to get the data types of all the features in a data frame, we can do .d types. This gives us the data types for each feature. So we have floats, ints, and categories. Please note, when you read the data from a CSV or an Excel sheet, you may not find this as a default option. Like the category might not be visible, you might see this as an object. But since this data is already available within Seaborn library, it has these variables classified as categories. Category essentially is a subset of objects. When we are referring to categorical variables, we are referring to objects with very limited levels. For example, when we talk about gender, this data has only 2 levels for that. When we talk about a smoker, it only has 2 levels. When we talk about day, it only has 4 or 5 levels here. Similarly, for time, we have only lunch or dinner as the options. So category, you can say, is a subset of the object data type. When the values attained are limited, it's called category. Let's check the shape of the data frame. So it has 244 rows and 7 columns. We saw the columns here, and it has 244 rows. We might want to check if we have missing values in the data. Quickly doing is null.sum, and we don't seem to have any missing value in any feature. Now what we can do is we can check if we have any duplicate row in the data. So there's one duplicate row, but there's nothing to worry about because we don't have an ID associated with any row here. It's not that we're referring to a particular instance of a customer visiting. When it's a restaurant, they're selling the same items. I'm assuming that will be through a menu. If they're offering the same items, there could be multiple instances of females who visited, who have had the same order, and they probably left the same amount and changes the tip. So there's nothing to worry about here. Seeing this one duplicate record, we can just live with it the way it is. And we can quickly do a describe to understand the nature of the spread of these numerical variables. So you can see the minimum value for total bill is $3.07 and maximum is $50.81. Similarly, the minimum tip is $1 and maximum is $10, and minimum at least one guest would have visited, and that's why it says one person, and maximum there were 6 guests occupying a table. Now we will systematically start the univariate analysis, and this is totally in line with the prior videos where we've explained the approach to data visualization. We don't randomly assign plots to different data types. The plots are predetermined. We're talking about a variable called tip, which is a numerical variable, a continuous numerical variable because it has values in decimals as well, as you can see. So the plotting choice, first choice would be a histogram, and Seaborn has a specific method for that, which is called histplot, where we can mention the x variable. On the x-axis, we want the tip values. Data is the same data that we have read, which is known as the DF. So we are dividing the tip amounts into 10 bins. Between a minimum and maximum value, we are putting 10 bins. This will determine the bin width like this. So maximum minus minimum, which is the range, divided by the number of bins we choose, will determine the bin width. We're giving it a title and doing a show. Let's see what we get as an output. So here's a histogram. It shows the values vary between 1 to 10, which is what we saw in describe as well. And majority of the tips were in the range of, let's say, $2 to $3. Similarly, for a univariate data, which is numerical in nature, we can do a density plot. Density plot essentially plots the probability density function and outline a smooth outline of this kind of a spread. Let's see what does it give us. So here is a density plot. Notice we have given some additional inputs like fill here, which is essentially to ensure that we don't just see this outline. If I don't write this fill, it will be just a white blank space in between a blue outline. But with a fill, it looks a little nicer. And you can see the values on the y-axis are no longer the counts like histogram. The values here are the density value. Similarly, for this data, we could have done a box plot as well. So we have very easy functions, very intuitive function titles. KD plot to get this one, hist plot to get the histogram, box plot to get the box plot, of course. Let's just do this. So here's the box plot. Notice I've given the input as y is equal to tip. So when I mentioned y-axis would take the tip values, you got a vertical box plot. If I would have written this as x equals tip, it would have given you a horizontal plot. Box plots are essentially 5-number summaries. They talk about the quartiles, Q1, which is the 25th percentile, Q2, which is the median, and Q3, which is the 75th percentile. Then you have minimum and maximum values, and anything that goes beyond the maximum value on the upper end or below the minimum value at the lower end would be called an outlier. So we have some outliers present in the data, and box plots are the best visualization tools to detect the presence of outliers. So while we have done these 3 plots, is there a way that we can do a comparison between these 3 plots? And this is something you would have seen in your matplotlib tutorials, but let's just do a quick refresh. So what we are saying is that we want to create subplots. Notice there is something else that's known as subplot, but we are using subplots. We are dividing the plotting area into 1 row and 3 columns. We've mentioned the overall figure size. And what this axis argument does is it would allow us to decide at what all places in this arrangement of 1 row and 3 columns we want to place these plots. So in Seaborn, we have an option to customize the placement through the plot itself. You have an axis parameter where you can pass the level. So if you write axis 0, it simply means that you are pointing to the first location in this arrangement of 1 row and 3 columns. Similarly, we are placing KD plot at index 1 and box plot at index 2. Notice we have set the titles, labels, etc. in the same fashion. We are choosing the right axis and we are doing a set title. If it was a matplotlib arrangement, even for the plot, we would have used something like this, and we would have not passed an argument here. We would have written like axes 0, 0, and this would have been a plot. But let's see what is the output we get. Finally, we are interested in having these plots nicely separated. So we are using a tight layout. And this is a very convenient thing. See, so in one view, you have the histogram, density plot, and box plot. So while I understand people who are not very comfortable with writing code might be wondering, why we've done this much hard work, I'll just show you in the next step how this saves us a lot of time. First of all, this view itself is amazing. It's interesting because we can compare all the plots and get to know what each plot is trying to represent. It's for the same variable, but still, for example, the information and outliers that box plots can give you, other plots won't be able to give you that clearly. And maybe information about the way you're able to see in the histogram for each bin, you don't see that anywhere else like that. And density plot would essentially talk about the skewness of the data. Is your data right skewed or left skewed, or it's nearly normal and things like that. So all these things matter at different places. It's good to know that we can look at different plots altogether. If you see in this code, for the rest of the numerical variables, if I have to see the plots like this, I just have to change one place. I'll have to write the name of that variable. Exact same code would be copy pasted, and we will just change the name of the variable and we'll quickly see the output. That's where it's a time saver. Let's do that. So I've just changed the tip with the total bill here, and everything else here is identical. There is no change in the code here, and in just one click, we'll be able to see the same information for the total bill. The total bill ranged anywhere between $3 to $50, if you remember, and this again has some outliers, some extreme values. 50 itself is an outlier. Same thing for the size variable, which is the number of guests. So if we do this same code, and with just one change here, instead of tip, I've written size, I can do this plot as well. So size, if you see, would not be a continuous variable. That's why it looks a little different. Why? Because you can't have a 1.75 customers visiting. You could have either one person or 2 or 3 and so on and so forth. So that's why you have the bars somewhat separated, because these are discrete numerical variables. So is the case with density plot. You can see that it's trying to join it through a smooth line, but you see these peaks here, multiple peaks here, and it again has some outliers. So it looks like it's not very common for the restaurant to have 6 or 5 guests at a table. Now let's move on to combined visualization. So what you've seen so far are different plotting choices related to the same variable. But would it be of interest to look at maybe 3 density plots or 3 histograms of 3 different variables? That'll be even more interesting. How do we do that? Not too many changes. We just need to decide which type of plot we want. So let's say we want to compare histograms of tip. There's no change in the kind of syntax that we've written here. We have given it a color choice. We have taken a histogram for the total bill. We have taken a histogram for the size. 3 different numerical variables. All 3 would generate histograms. And we have used the same arrangement of the axes. So plt.subplots, 1 row and 3 columns. And the first plot will be tip, then total bill, then size. And tight layout to nicely separate the plots. Let's see, right? So you have the histograms with the KDE option is equal to true. So it simply means that it will also show you an outline of the density plot here. You get an idea about the 3 plots together in one. Can we make this code a little more efficient? For example, let's say we had 20 plots to create. Would we be typing this much every time for every single plot? That's where the loops come handy. So what we can do is we can simply create a list of features like tip, total bill, and size. And for the titles, because we would want the titles to be dynamically assigned, we are creating a list for the titles as well. And then we are simply running a for loop. We are going over a range from 0 to 2. When I say range 3, it's going to take values up to 2, 0, 1, and 2. Why? Because these 3 items in a list would be indexed as 0, 1, and 2. So would be the case for these 3 items. We are simply saying that we will choose the column index 0 first, which will be tip. When I choose 1, it will be total bill. When choose 2, it'll be size. And likewise for the axes also, we will go with 0, 1, and 2, which will be the 3 choices for the axes. So we've got the colors here that we are customizing with, and color would again be chosen as per the sequence. Let's just run this. You'll get the exact same output in this case as well. But this code, of course, looks more concise. And like I said, if you add 20 variables, it'll be very difficult to write every time for 20 variables each. You can simply put it through a for loop. This much code would be sufficient. You'll only have to change this value to 20. It'll go from index 0 to 19. And it'll show you all the plots. You'll have to choose the subplot choices accordingly. You may not want to put them in 1 row and 3 columns. You can say choose a 4x5 grid. So 4 rows and 5 columns. Each row would have 5 plots in that case. Comes very handy when you have to do data visualization and you have too many variables. Now let's move on to the categorical variables. And we are again talking about the univariate analysis. So in case of Seaborn, we have very handy choices. Just sns.countplot would give you the count plot for the categorical variable called gender. And we can give it title, label, and all like the matplotlib way. You got the count plot for gender. Likewise, if you want to do a pie chart, we have a plt.pie. So plt.pie is not the same as what you get from Seaborn. Seaborn somehow doesn't have a very good choice for a pie chart. So we'll have to stick to the matplotlib way of doing the pie chart. And what we have to pass as an input here would be the value count. So value counts on a variable essentially gives you the count of the values in that feature. Let's just give you an example. So let's say we take the gender column and I, on top of this, just apply value underscore counts. So it has to be typed properly, otherwise it'll give an error. Value underscore counts, and if I run this, what do I get? I get the count of males and females. This is the information we're giving as an input. Then we are saying that we want the labels as per the value counts index. What is the index of this? Male and female. And we are using auto PCT, which is going to keep the percentages obtained by dividing these values by the total up to 2 decimal places and with a percentage sign intact. Here's what it is. We got a pie chart, says 64% of the guests were males and 35% were females. And if you want to put these two together, again, similar arrangement, you can use plt.subplots, 1 row and 2 columns. Choose the first plot, which will be the count plot in our case, the second plot, which will be the pie chart. But notice the difference here. Now it should come very clear. For Seaborn, you have an option to choose the axis as per the parameter. But for matplotlib, you can directly attach the plot to the axis. This is the difference. For Seaborn, for setting up the title and labels, you still follow the same convention, which matplotlib follows otherwise. Only for the specific plot placement, you have the parameter called axis where you can give the input. And let's run this. So you got the 2 plots together. Now you realize how easy it is going to be for us to choose any categorical variable and get this output. All we need to change here would be the fact that it's a smoker that we are looking for, and we have to give the right inputs here accordingly. So it's exactly the same code that you saw earlier. All you have to change is the name of the feature. Earlier, it was the gender. Now it's the smoker. Let me run this. All right. So you see, majority of the guests were non-smokers, and non-smokers were 62%. 38% of the guests were smokers. Similarly, if you want to check it for the day of the week, what all days of the week do we have? And this would be a representation of the frequency, how many people visited on what all days. We can always do this. Just one change in that previous code. Change the variable to day. That's it. And that's where it saves you a lot of time. So what can we say when we read this? We can easily say that Saturday is the busiest day, followed by Sunday, then Thursday, and looks like Friday is the leanest day. And we don't seem to have any data for the remaining days. For example, we don't have any data for Monday, Tuesday, and Wednesday. Maybe this restaurant operates only on certain days in the week. And if you want to see the same information converted into percentages, you can obviously see that for Saturday, you have 36% of the overall visits, 31% on Sundays, 25% on Thursdays, and Friday is the least, which is only 7.79 or around 8%. So this is about the day of the week. Now, if you want to check for the time, like are more people visiting us during the lunch or dinner hours, we can change the variable to time, exact same code, and we can run this. What do we get? So it looks like this restaurant is really popular for dinner. There are very few visits for lunch, and 72% of the visits that we have are there for dinner only. Only 28% visits are for lunch. So dinner is their peak. Now, once again, if you want to see comparable options, like we want to compare pie charts of all these 4 categorical variables, namely gender, smoker, day, and time, we are doing something similar. We have divided the plotting area into 1 row and 4 columns. And for the appropriate choice of axes, we are assigning the plots. Since it was a pie chart and we got it from matplotlib, we will not be using the parameter, but we'll be passing it directly to the axis. So let's just do that. So see, you got the same pie charts here for 4 different variables. This is how it comes very handy. And if we want to make this code even shorter, we don't want to write this much for 4 variables one at a time because we may have more variables. We can conveniently use a for loop. So we are going over a range of 0 to 3, which will be 0, 1, 2, and 3. And then what are we doing? We are referring to this list, which is the list containing the names of the features and the list of titles. The list of titles will be used for setting the title, and the list of features will be used for choosing the appropriate feature. When we say columns index 0, it would mean we are referring to the gender column. When we say index 1, we are referring to the smokers, 2, we are referring to day, and 3, we are referring to time. A for loop will take care of that, and it will accordingly keep on doing the value counts and value counts indices and give out the pie charts with 2 decimal places precision. Here's the outcome. Same thing, a little more concise code. Like I said, it becomes more meaningful when you have more variables. So far, we only had 4 variables. You may not realize, but if you had 50 variables, it becomes important to look at something like